Hello, welcome to practice problems for chapter 14. Let's just start zipping right through these guys. So we've got here, consider this information for the next two questions. For 20x1, General Motorcycles earns 80 million of EBIT. So the income statement is partly completed for us. The firm's tax rate is 21%. Assume the firm's taxable income is equal to its EBT. So then we have these two questions regarding the firm. For 20x1, it's debt-free. Okay, good. What is the firm's tax expense for 20x1? And hint, if a firm has no debt, its EBIT is equal to its EBT. Okay, so clearly in this case, the tax is going to be on earnings before tax of 80, and we want 21% of that. So we'll say equal 21% times that 80, and we get 16.8. And then what we could do to complete the income statement here is say the net income is equal to the earnings before tax minus the tax. And that's 63.2. Yahoo, good for us. Okay, next up, if General Motors has debt of 16 that carries an interest rate of 9%, how much does its tax increase or decrease compared to its debt-free state? Okay, so we already know the tax in its debt-free state here with no interest, so we just got to do the same thing with the situation of this tax. So EBIT is not going to change, right? Earnings before interest and tax, no change at all. But now we have an interest payment. Okay, so we need to get the interest. We need just the 9% times the 16. Okay, so that's 1.44. And now the earnings before tax is equal to the 80, the EBIT minus the interest of 1.44. So that's 78.56. And now the tax is 21% of EBT. So we'll say 21% times our EBT, and that's 16.4976. And once again, let's go ahead and get the net income, which is our EBT minus our tax, just to complete the income statement. And now the difference is going to be, there's going to be more tax if they don't have the debt, right? So we start with that, and we want to subtract from that the tax they pay if they do have interest. It's less tax because of that tax shield effect, right? And that's 0.3024. So we could say GM will pay 0.3024 million less tax. And that's, again, due to tax shield effect. Next up, a firm has debt outstanding of 20 million at beginning of year one and pays 1 million interest in that year. At beginning of year two, the firm increases its debt outstanding to 22 million and pays 2 million interest in year two. What's the firm's pre-tax cost of debt in year two? Okay, so this is one where maybe more information is given to us than is needed, but to get the RD in this case, all we care about is interest in the year that we're interested in divided by outstanding debt at the beginning of the period. So let's see if we can do that. We want this for, the question is for year two. So what's the interest that it pays in year two? That's 2. Okay. And at the beginning of year two, the firm increased its debt outstanding to 22 million. So we just take that 22, divide 2 by 22, and we get 0.909. And again, that's equal to the interest in the year. That's 2 over the beginning of year total debt, which is 22. Next up, a company borrows 15 million from a bank, agrees to pay 10% annual interest, and agrees to repay the principal in 3 years. Very common loan contract. What is the closest to the pre-tax cost of debt for this project? Hint, the pre-tax cost of debt capital for a loan or bond project is the IRR of the expected project, including all the cash flows, and we could even say in here all the promised cash flows, because we always want to be assuming nothing's going to go wrong when we do this calculation. Okay, so we have two possibilities here, IRR of 10% or IRR of 5%, and we just want to see which one is right. So we're just going to use the IRR equation for this, and that's going to give us the pre-tax interest rate when we find the right one. So let's make sure we have the cash flows right. So the company gets at t equals 0, 15 million, and then they pay 10% interest after a year, another 10% interest after 2 years, and after 3 years they pay another 10% interest, and they repay the principal of 15. So that's why we have a total of minus 16.5 here. And what I'm going to do, you could do this with GoalSeek in Excel, you could do a lot of fancy things. I'm just going to literally try 10% and then try 5% and see which one works here. So I'm going to do it all by hand. Okay, so we want to see if 0 equals the present value of all these cash flows discounted at 10%, because that's our equation for the IRR, right? It's the NPV that makes all the present value of all the cash flows equal to 0. So I'll say 15 plus, let's make that minus 1.5 divided by 1 plus 10% and minus 1.5, etc., etc. So I have 1 plus 10% squared for the second minus 1.5, because that happens at end of year 2. I need to discount that back by 2 years. And then finally I get to my third year payment. So that's going to be divided by 1 plus 10% raised to the 3. Okay, so that's the question. So let's see if this is true. So I'm going to just paste that in over here and let Excel calculate it for me, just exactly the same way you would do it in a calculator yourself. And look at that Plamo. That makes me so happy. Yahoo for that, because now I don't have to do the same thing for 5%, so I've just saved myself some time. So we found out that using 10%, we satisfy the IRR formula. So that's the one that we want. So the cost of debt capital pre-tax for this project is equal to 10%. All right, let's keep going here. In the equation, RD post-tax is equal to 1 minus tax rate times RD pre-tax. The term 1 minus tax rate is often called the tax yield. True enough, using this terminology, if a firm has a tax rate of 25% and 50 million debt outstanding with an interest, 25% and 50 million debt outstanding with an interest rate of 10%, what is the tax yield? Well, this one is actually a lot easier than it seems once you get through the wording, because it says using this terminology, what's the tax yield? So this terminology says the tax yield is measured by many people. It's described as 1 minus the tax rate. So that's going to be equal to 1 minus the tax rate is 25% or 75%. And that's it. It's that simple. So that would be the tax shield using this definition of tax shield, which is a very common definition. Okay, finally, given the following information, what is the equity cost of capital, RE, using the CAPM model with these inputs? Okay, so remember that RE is equal to RRF plus beta times RM minus RRF. And it's really that simple. And we have all the information that we need here. So that's going to be 5% plus 0.45 times RM of 6% minus 5% RRF. And we get 0.0545, otherwise known as 5.5%, and that's it. So that brings us to the end of our practice problems for Chapter 14, so I'll look forward to catching up with you again soon.